Hello everyone, and I welcome you all in mathematics class here. Yes, and today we are going to study the chapter integers, and the topics I will explain here for the exercise 1A. Okay, now you can see here we have to discuss the points that properties of addition of integers and subtraction of integers here. So let us see and try to understand first of all that properties of addition of integers. Okay, so what points are here? So closure property of addition first of all. So what we can understand from this term, that the sum of two integers is always an integer. Listen that. The sum of two integers is always an integer. For example, we can say 5 plus 4. Here 5 and 4 both are the integers, so their sum 9 is also an integer. Similarly, 4 plus minus 9 equals to minus 5. So here this sum is also an integer here. Now next we have associative property of addition. So in this we can say that if A, B and C are three integers, then if they are following this grouping, means A plus B in bracket and C is outside, and on the LHS side and on RHS side you can see A is outside the bracket and B and C are in group because they are in one bracket. So in such a way, if you will add the numbers, you will see that both the sides are equal. Okay, for example, you can see this 3 plus 8 in the inside the bracket plus 4, it will give 15. 3 plus 8, 11 plus 4, that is 15. And now RHS side also we can evaluate. It will come 8 plus 4 inside the bracket, then after that 3 is also there, so total 15 is the result. So this way we can say that addition of integers is following the associative property. Okay, now next we have commutative property of addition. Here what, if we are changing the order of addition, order of the numbers in the addition process, then also if their sum is same, then we can say the addition of integers are following the commutative property. So we can write in this way that if A and B are two integers, then A plus B is equals to B plus A, means if you will change the order of the numbers, okay, then also their sum will be same. For example, 9 plus 5 is equals to 5 plus 9, and both are equal to 14. So that's why it is following the commutative property. One more example here, minus 7 plus 3 is equals to 3 plus minus 7, and both are equals to minus 4. Both are equal to minus 4 here. Then existence of additive identity. So we all are knowing that 0 is the additive identity of all the integers, because by adding 0, the sum is the number itself. For example, here for any integer a, we have a plus 0 equals to 0 plus a, that is equals to a. So that means when we are adding 0 to any integer, its identity it is same only, it is not changing. So that's why it is called the existence of additive identity, means minus 3 plus 0 is equals to 0 plus minus 3. Okay, and similarly 4 plus 0 here in the second example, 4 plus 0 equals to 0 plus 4, means both the sides are equal to 4 here. So by adding 0, the number is not changing, the sum is the number itself here. Okay, so 0 is called the additive identity for all the integers, because by adding 0 there is no change in the number, the result, the sum is the number itself. Then existence of additive inverse. So what is additive inverse here? For any integer a, we have minus a also, which is the additive inverse of A. We all know that additive inverse of A is minus A and additive inverse of minus A is plus A, and in this condition always their sum is 0. That means the sum of an integer and its additive inverse is always 0. Such as here example we can see minus 9 plus 9 is also 0. Now we have subtraction of integers. So some questions here. Subtract 8 from 5. So we can solve in the given way. 5 minus 8, because from 5 you have to subtract. So 5 minus 8 equals to minus 3. Here the larger number is being subtracted from the smaller number, therefore the result will be negative. Okay, only find the difference between 8 and 5 and give the sign of the greater numerical. You can say, you can do this also, but better what you will do here, whenever you will see that you are subtracting the larger number from a smaller number, then their difference will be always negative. Okay, the result will be always negative here. Okay, in this operation actually you can see that 8 is the greater value, therefore in the result also you will put the sign of greater value, that is minus. Okay, now we have other question, that minus 9 from 7. So if minus 9 from 7, you will do what? 7 minus minus 9. This minus is the middle minus here, that is used for the subtraction, and that minus 9 is the sign of 9. So 7 minus minus 9, that minus and minus we can multiply. So result is 7 plus 9 means 16 here. Okay, now here both the numbers are negative. Subtract minus 8 from minus 2. Then we can write in the given way that minus 2 minus minus 8. Again these two minus signs in between, they will multiply by giving the result plus, because minus into minus equals to, that means negative into negative gives the result positive. So minus 2 plus 8 we can write it is 6, because here minus 2 and 8 having the opposite signs. So find the difference between them and give the sign of the integer having greater numerical value here. So 8 has the positive value, so result is plus 6 here. Now the simplification question here, minus 13 minus minus 27 plus inside the middle bracket minus 25 minus minus 4. So you will follow the BODMAS rule also here, because it is simplification. So first of all write the statement expression given in the question, then write evaluate that these two minus signs here you will evaluate first, minus into minus, here also this minus into minus, so that giving the result positive here. So minus 13 plus 27, this will you will calculate 27 minus 13 means 14, this is 14, and this is minus 25 plus 40 means it is 15, because we can also write them as 40 minus 25 by changing the order. So while changing the order you will not change the sign. Okay, sign of the number will be same, so you may write that 40 minus 25 also. Okay, so that will be 14 plus 15, that means the result is 29 here. So this way you can solve the questions of exercise 1A, okay, nicely from the R.S. Agrawal book. Okay, students, so now do watch this video nicely and try to understand, and thank you all of you. Have a nice day.